All right, a second ago I said that we're going to look at the key to this worksheet, and I reminded you of the instructions here because they were often forgotten by other students. I didn't mean the key. I meant we were going to look at some problems from it. And we started with the first one there, that one. This was problem number 5. There's a typo, I believe, in it originally. This was number 6 from that problem, fully done. So 5, 6 from that worksheet. What worksheet am I talking about? This worksheet. It's attached. This is our worksheet number 3. Okay. I believe there's one more. Nope. I think that was the only ones I did from those in class. So that should get you started anyway with where we did in the class. Then we did today in class Tuesday, September 3rd. We looked at this is our do now from today. Pretty much the same task-driven, self-pacing goals, and then we have rainbow packs. Practice the 5 and 5 list. That'd be the 5 indicators and the 5 types of reactions. To practice those, I wrote them on the board and I kind of demonstrated them again. There they are. Here are the types. I give you the types along with a shorthand abbreviation. Let me change that color. It's not very clear. Give you a shorthand abbreviation for synthesis. And also the skeleton generalized format, A plus B yields AB, which is the key giveaways that it always produces a single substance product. And that's counter to the decomposition, which always produces a single substance reactant. Take away that last one. Or which always has a single substance reactant, the AB reactant, that then divides into A and B, called decomposition. Composition or combustion, is is C, and it always is the whole reaction as a total only has C's, H's, and O's in it. Okay, but it also always only has an O2 reactant and CO2 and water products always. And then the other reactant is a hydrocarbon, which can have an oxygen also, but normally does not on most of these combustion reactions. But it's a hydrocarbon, which means it has carbon, hydrogen only, as those special naming rules from the bonding unit. Then single displacement is an A plus BC, and there's a different if A is a nonmetal, like chlorine. Could say this one was A if A was a nonmetal like chlorine, and it was Cl2 that bonds with a BC, sodium chloride, or sodium. Let's get rid of both of those. Bonds with a sodium Na fluoride, for example. It's Na. Where sodium brings a 1, fluorine brings a 1, so it's just NaF. Produces, well, first Cl is a nonmetal, F is a nonmetal, so they swap places, it becomes NaCl. Plus now the F is alone. But F is a diatomic molecule because it's part of Hahn-Cliff bar, so it becomes F2, and so on. In this case, it should be like zinc or some sort of metal with a non-metal situation, so Zn, with a compound that involves a metal, perhaps sodium chloride. This wouldn't actually happen in reality, but yields sodium and zinc are both metals, so they swap places. Becomes zinc chloride plus sodium. Now sodium is the loner in this case. That'd be the two different examples of single replacement. It's just switching compound partners, you could say. But one's a loner. Now double replacement is the same thing, is the similar to single replacement, except for instead of one going from loner to partnered, both substances, all four, or all ions, all elements, all partners are partnered up. And they just swap partners. But it's still got to be cat with anion on the other side. So one strategy is to label each of these partners, like the AB, call it a 1,2, and the CD, call it a 2,1. And then reconnect the ones together, so the A with the D. But A came first over here, so it needs to come first over here. D came second over here, so it needs to come second over here when we list it. And then CD, or BC, so we would do C was first, so it needs to be CB, not BC, because B is the anion and C is the cation. It needs to come in that exact order. They're just swapping partners. It's helpful to use to label it like this. We've done so many examples of double replacement, it's unbearable. But I'm going to show you some other ones like this right here. Look, you've got on this exact problem, you've got, where did my pen go? You've got a 1 with a 2. And H is a 1. Nope, sorry. But the formula is do 1, 2, 2, 1. Sorry, y'all. So we would say this H is a 2, and this PO4 is a 1. So we want the Na and the PO4 to get together, so that it's 1, 1, and the H and the OH to get together, so it's 2, 2. Okay, let's look at another one just in case. Alright. Alright, in this case you have NaOH. This is the same one as one before it. Real quick. This is a single replacement. Calcium's alone. Swatch it, swaps, and now you got hydrogen alone. Single replacement. This is a combustion because we have oxygen, yields CO2 and water. This is a double replacement because we have a 1, 2, and a 2, 1. The 1s recombine, 1, 1, and the 2s recombine, 2, 2. Now when they recombine, of course, in the reaction, we still have to take into account their charges. So here BA brought a 2, OH brought a 1, crisscross, we got the formula we got. BA brings a 2, PO4 brings a 3, we crisscross them down. We still have to follow our rules for writing chemical formulas. So that's no change there. Same thing, H brings a 1, OH brings a 1, so we just leave it as HOH or H2O. Remember, we rewrote H2O as HOH because that's a strategy of ours. Okay, let me clear this up. Number 2 here is a synthesis reaction because we have an A substance and a B substance forming a total combined substance. A, B, or excuse me, yeah, this is an A, B, and a C, D, so that's another double replacement. The majority of these ones are actually double replacement on our other page, on our practice pages. So, those are our 5 types. I don't want to beat this dead horse any more than I already have, but those are our 5 types, and that was on the list. That's one of our 5 lists. You were to memorize those and practice those. I just want to rehash them again. I know I did it once. I want to just do it again. Okay? So, other things up on the board. There you got the other list of 5. This is our official list. Pay attention here. This is the official indicators list. Indicators of a reaction. Evidence a reaction took place. 5 reasons, symptoms, actions, things, 5 events that indicate a reaction has taken place. They don't all 5 have to happen. Usually 2 to 3 of them will happen, but just for the record, these are demonstrated. These are what features that demonstrate a reaction across the board every time, all the time, every time. So let me go back to it. Those are the 5 indicators of reaction. Those are 2 lists of 5. I had you tell a neighbor, I had students tell a neighbor from memory, and then do the first quizzes on GC. That would be the 20-question chemical equations practice quizzes on GC. And then get straight to work on the tasks. What tasks am I talking about? That would be this first picture. Balancing equations, worksheets, and practice. Balancing review and practice. Quizzes. Review worksheet. Other practices. Indicators of a reaction lab. I'm going to demonstrate that as soon as I get a chance. I'm sorry, I just can't do it right this minute. Balancing chemical equation exam, that's tomorrow, and then credit recovery items, and then I gave some an announcement on the credit recovery items. I'll show you that in a second. First, take a look here at the review. Here is the review. And I can't remember if I posted this online or not, but I will make sure it is. Here is the review for you to do and prepare yourselves for the exam. It's just more of what's going on. The exam tomorrow will feature 8 multiple choice questions. This is a mini test. Counts just like a whole test, but it's mini in terms of how short it is, how easy it is to grade, really how fast it is to grade, and how long it normally takes in a class period. 8 multiple choice questions. List the 5 indicators. Then on the back side, there's reactions, just like we've done with all these other practice worksheets. There are several different chemical equations shown to you. There will be straight up skeleton equations, which just means like this one, N2H2. It just means it gives you the chemical formulas, not in word form. This is how the exam will look. It'll be balanced skeleton equations and name the type. It'll be word form, you write the skeleton, balance it, name the type. It'll be word form, reactants, write the reactants, predict the products, balance it, name it. And then finally it'll be skeleton, reactants, predict the products in formula form, balance it, name the type. So 4 different varieties of types of questions, which they're all the ones, if you went through all the practice problems and said, oh yeah, just writing the balanced equations, or just balancing the equations with coefficients, done. You're going to see those again. Predicting the reaction and balancing, you're going to see those again. Writing the word form and then balancing, you're going to see those again. Taking the word reactants, word form of the reactants, writing them, predicting them, balancing them, naming the type. You're going to do that again. You're going to do everything you did in the practice problems in a shorter format on the exam with different varieties. So nothing shocking here. It is what it is. It's exactly what we planned on doing, exactly what we prepared for doing, and that was the exam. The rest of the day was just spent working on these items, and then we got into some credit recovery type item options. This can be hard for you if you're remote, but depending on the scenario, I can still allow you to do it after the fact. And that credit will just have to roll over. I would just have to simulate what that credit would do in the first 9 weeks, and then roll that credit over into the second 9 weeks. But we'll cross that bridge when we come to it. As I'm aware, some of you who are on quarantine right now are actually going to be, you're very capable in terms of your assignments in general already, so I'm not very worried about that you having to recover much. So anyway, we'll talk about that when you get back. You can send me messages, let me know if you have any questions. Look for the test coming out soon. Good job, keep it up, and let me know what you got going on. Once again, stay tuned for the reaction indicators demonstration coming soon. Go Dogs.